take her spot.
Am I in the way? No, you're good.
You sure?
Yeah.
Okay.
Thank you.
So how's your list?
Thanks for the
Even though I'm like,
That's okay.
That was Olivia.
Sure, fine.
With some joy. I like that enthusiasm. Okay, nice.
Sorry, I have like 3 pages because I kind of thought about it first.
Yeah. Good. What do we got over here? Oh, very good. Very beautiful. Good. Very nice.
I forgot to put my examples.
That's okay. I wasn't clear on that.
I have space for my examples.
Good.
What I did.
Do stuff I have
We made
space
this
for
list
them.
together instead of so I don't have it written down yet.
Oh, okay.
I think we got like a view,
I just
but
have to write it
I
down.
have less space for.
Okay. Very good. Did you guys, I couldn't tell really when I was going around, did you organize them into some kind of categories or?
Um,
Yeah.
Yes, no?
They're in clumps of categories, but some of the categories are split up. So, kind of.
Okay, let's try to sort of compile, and then maybe I'll have a chance to work this weekend on like typing it up and organizing it for you, and it looks like, I was gonna kind of collect them, but it looks like some of you like want it the way that you did it on your own, and that's fine, and you have your examples, and or you have space for your examples on your paper, and that's fine too. So, we started our list yesterday, and just so that none of us have forgotten anything. So maybe kind of check them off as you go. Who has categories, and what are your categories? Natalie?
I just went like all the postulates, then all of the definitions, and all the theorems, then all the definitions.
Okay. Hannah?
All the postulates, all the theorems, and then the properties of equality, the properties of inequality.
Okay. And, I think I'm gonna organize mine a little bit differently, if you don't mind. I was thinking maybe it would be easier to find things that you're looking for if they were organized more categorically, right? So like the properties of equality and the properties of inequality, that was back in chapter 1, right? Those could all go together, and that would be the substitution principle, and the transitive property would be in there. There we go. So let's start with the postulates and theorems of equality. And what do you guys have for that?
The screen is black.
Yeah,
Oh,
screen.
thank you. And now? Good? Okay. So what do you have for the postulates and theorems of equality? Did anybody put any of those down? None?
I have multiplication properties of equality.
Okay. Someone else? Morgan?
Addition property of equality.
Good.
Commercial property.
Good? Right?
Division property.
Good? I already have this one. We already put transitive property the other day. And what are we missing? Do we have any other properties that we want?
Symmetric property.
And that is true, but have we ever used the symmetric property? So let's leave that off for now. Yeah?
Reflexive property.
We have used the reflexive property. Okay, 1, 2, 3.
Are we writing this down, or are you gonna like print it out for us?
I am going to organize this for you guys. I just wanted your help in making it. So you don't necessarily have to write all this down. Okay? Sorry. I'm not clear about that. Sorry. I feel like it's been slightly unorganized. My whole point is trying to get organized. Alright, and then we also have the postulates and theorems of inequality, which are all the same except for the reflexive property. Okay, what else? And then we have a substitution principle. So these are all like the general ones that it doesn't really matter what topic we're doing. These could be used in any topic, right? Is there any other ones that could be used in like any topic that you can think of? I can think of any either. Okay, so then let's talk about, we have the angle addition postulate. Before we get to angles, let's talk about the ones that we have for lines and line segments that we've used. What do you guys have related to that? Aaron?
What I have is the definition of right angle is one, I guess.
Let's put those with angles.
Oh, angles, okay.
Okay.
Oh, lines.
The definition of point, line, plane, space, collinear, and coplanar. Like all the definitions.
Which ones of those have we used in proofs so far? If we haven't used it to this point, there's probably a good chance we won't, and so I don't want to put it down if we're not going to use it. Have we used any of those? So you guys can think of Madeline?
Definition of congruent segments.
Okay. Okay.
Definition of opposite ends.
Have we used that?
Yeah.
Yeah? Okay. Next.
Definition of between.
That's a big one. Definition of between. Hannah?
Definition of the midpoint of a segment.
Matt?
Definition of a bisector.
Okay. Anything else that you guys came up with between two lines or line segments?
Definition of congruent segments.
We We got that? Thank you. Good. Aye.
I'm confused about something.
Yeah.
Because there's like a definition for, the midpoint of a segment, but then there's also a theorem. So which one should you use?
Where is the theorem? That's
Theorem 1.5.
Theorem 1.5. I don't know if you guys remember me telling you, but all the postulates and theorems are in the back of the book. Page 493 and 495. 1.5. That one is saying that a segment has exactly one midpoint, which really isn't very useful in general with proofs. The definition of a midpoint is what tells us that the lengths of each of the segments are congruent. You know what I'm saying? So theorem 1.5 is just saying that every segment only has one midpoint. There can't be more than one midpoint of a segment. But the definition of a midpoint is more specific, where it gives us information about what that midpoint tells us. And it tells us that it will divide the segment into two equal parts. Okay? Morgan?
The roller postulate?
The ruler postulate? I'm not sure. Have we used that too? What?
Yes.
Okay, good. Let's look at these other. Any others that we've used frequently or at all? No?
Postulate 5.
Yeah, I was looking at 1 through 6 and we might use them occasionally, but not very often. For any 2 points saving. I'll just put postulates 1 through 6, and then if I can find an example of a proof. Did you have an example for number 5? Matt?
No.
Okay. Some of you came up with examples and stuff. All right. All right. Then angles. We already put yesterday the angle addition postulate. What else do we have pertaining to angles? Yes?
Definition of adjacent angles.
Okay. Aaron?
Definition of vertical angles, I think.
Okay. Okay.
Definition of perpendicular angles.
Definition of perpendicular lines, right?
Definition of congruent angles.
Good? Morgan?
Have we used like definition of acute angle, right angle, obtuse?
Yes, we have.
And supplementary angles.
These are the definitions of subject and complementary.
Yes. I'm gonna put those all together. Acute, right. And definition of complementary and supplementary angles. Okay, good. Madeline?
Definition of bisector of an angle.
Definition, I'm gonna call that an angle bisector. Okay, good.
Do you want like the theorems 1, 2, 3, 32, 7, 9?
Some of those are very useful. Like, which one have we used the most? Oh yeah, the ones that we just had. Is that what you mean? 2-3 says an angle has exactly one bisector, I don't know how useful that is. But, 2-4, 2-5, 2-6 and 2-7. Yeah. So here, and there's another one we had earlier in that section that was very important. Mac,
Theorem 2-1.
theorem 2-1. And then that's 2-2. No, we don't do 2-2. 2-3 through 2-7. And there's, I mean, we're gonna be adding to this list, obviously, throughout the year. Right?
The protractor postulate.
Protractor postulate.
Today,
Postulate 8 is another one. Let's see. For every angle, okay. I think we have used that. That was
Would we also do like guaranteed lateral, guaranteed timing, and then guaranteed everything forward?
oh yeah, we have those.
Yeah.
Yeah, we are through 2-12, you're right. So theorem 2-3 through 2-12. Okay. Okay.
The angle addition question.
Yes, we had that from yesterday, so we have that. Okay. Anything else that we forgot? Okay. I will start a list and somehow we'll find a way to keep it so we can add to it throughout the year. And where we have examples for you guys to look at as well. Okay? Alright. I do want to do another proof from section 2-6 today. So if you guys would have your notes out. And your book is going to be number 26, I think, on page 63. Okay. So 26, you have two lines here, and a line here. There's 1, 2, 3, 4, 5, 6, 7. And we're given that the measure of angle 2 equals 120, and that the measure of angle 8 equals 60, and we have to prove that angle 4 and angle 7 are supplementary angles. Okay. So where shall I begin? Aaron?
Measure of angle 2 is 21. I mean, 120.
Okay, and that is The reason? Given. Okay, and ultimately, we want to say that angle 4 and angle 7 are supplementary. And they have given us angle 2 and angle 8. Okay, so those are the 4 of the 8 angles that they gave us. We're really only concerned about those 4 angles. Okay, so any ideas where I would go next? Mac?
Well, 2 and 4, so angle 2 and angle 4 are supplementary, so you could figure out what the measure of 4 is.
Good? How do I know that they are supplementary?
So I think it's definition of supplementary angle.
I think it's a
Oh.
yeah? No?
Never mind.
I think it was at the beginning. You had it on your quiz. If I remember correctly.
Theorem 2-1.
Yes, theorem 2-1. Theorem 2-1, which says that if 2 adjacent angles, exterior sides form a line, then they are supplementary angles. Okay, good. So you said ultimately you want to see what the measure of angle 4 is. So how am I going to get there? What would I do next? What do I know about the angles if they are supplementary? Yes, so the measure of angle 2 plus the measure of angle 4 equals 180. Because of what? Yes, because of the definition of supplementary angles. Good? Okay, so then, how am I going to figure out what the measure of angle 4 is? Mac?
Can you say the measure of angle 4 equals 60, and then for the reason you would say subtraction property?
We should say one other thing before that. Because right now, we can't, like, we could subtract the measure of angle 2 for both sides. No. Sarah?
Did you say 180 minus 120 equals the measure of angle 4?
Yes, but looking at step 3, we don't have 120. So what do I need to do in step 4 first? Mac?
Oh, wait, never mind, sorry.
Sarah?
You plug in 120 for the measure of angle 2.
Yes, I need to put in 120 for the measure of angle 2. So I need to say 120 plus the measure of angle 4 equals 180 because of substitution. Yes. Okay, good. And then I can do what you guys are saying and say that the measure of angle 4 is 60 because of the subtraction property of equality. Okay, very good. So now I know that the measure of angle 4 is 60. And it would be helpful to figure out the measure of angle 7. But how do we know?
Are you going to use the same thing like you did in 4, but, or you're going to go back to 3 and then like use it with the
Yes, we're gonna do the same, very same thing to figure out the measure of angle 7. Mac?
Measure angle of 8 equals 60, given.
Okay, good. The measure of angle 8 equals 60, and that is given. And so if we had some forethought, we probably could have, remember yesterday how we did like 2 statements at the same time every time? We could have probably done that here and put both givens at the top, and then said angle 2 and angle 4 are supplementary, and also angle 7 and angle 8 are supplementary, because all of these are gonna have the same reason. So we could have done it pretty much all at the same time if we would have thought about that ahead of time, but we can do it this way too, okay? So then we would say what?
Angle 7 and angle 8 are supplementary angles.
Angle 7 and angle 8 are supplementary angles. Because of theorem 2-1, good. And then, what? Yeah.
Measure of angle 7 plus measure of angle 8 equals 180.
Good. Which is definition of supplementary angles. Good. So this is a long one, as you can see. And then, Hannah?
Measure of angle 7 plus 60 equals 180.
Good. Because of,
Substitution.
good. And then,
Measure of angle 7 equals 120.
good, because of,
Subtraction property of any, or equality.
good. Alright, so, now I know that 7 is 120, and what's the other one, 4? And 4 is 60. So, what will I say? Morgan?
Angle 4 plus angle, the measure of angle 4 plus the measure of angle 7 equals 180.
Okay, good. And what would the reason for that be?
Definition of supplementary angles.
Okay. Good, so then we can say that, Mac?
Angle 4 and angle 7 are supplementary.
Which will also be the definition of supplementary.
Wait, why wouldn't that one be theorem 2-1?
Theorem 2-1 is the one that says if they are next to each other and they share, or they're adjacent angles and their opposite sides form a line, then they're supplementary. Okay? Ready to do some for your homework?
No.
I want you guys to do 2 proofs this weekend. Numbers 23 and 25. They're on pages 62 and 63.
turning on essays.
Have a good one.
I had to return the whole thing, just add like the
So,
page numbers.
add to, I'll switch someone up.
That's all you have to correct?
Yeah, I'm just not
No,
sure.
I had to,
Go back to
yeah, I had to do it, but last night,
after.
like even after I had
Yeah.
already like rewritten it like 3
Um,
times. Like,
I didn't have.
So we'll see.
And I